It is my pleasure to be here. My name is Ghangshin Lee from University of Seoul. Welcome everyone to join my presentation today. During winter, black ice is formed on many roadways, and this natural phenomenon introduces many risks. The warning signs for black ice are generally ineffective because of the lack of credible information. To overcome this limitation, new warning signs for black ice were developed using materials that change color in response to different temperature. Therefore, related study must be conducted to increase their utilization to bring more awareness of how more effective signs to warn drivers about black ice are needed. As new warning signs are being developed, the evaluation method in a virtual environment using VR can efficiently determine whether the new warning sign achieved its goal as a warning sign. Accordingly, the performance and effect of the new signs were investigated by conducting driving simulator experiment with eye tracking device. The primary object was to investigate the effectiveness of the new warning signs that are actuated by weather conditions, and to investigate the change in driving and visual behavior regarding different warning signs. The UC Winroad program was used for interactive VR. The experiment employed an automatic car composed of a seat belt, steering wheel, speedometer, ignition and key unit, accelerator, and a brake pedal. The visual display system consisted of 3 color monitors spanning a 180-degree field of view synchronized to display a realistic view. The Tobii Pro Glasses 3 recording device was used for eye tracking. The study followed the Tobii manual definition of fixation, which lasted more than 60 milliseconds. To conduct such experiment, an evaluation method to analyze driver behavior using a virtual environment simulation-based driving simulator and gaze tracking equipment was reviewed. The equipment recruited 37 healthy subjects from our panel who occasionally joined our simulation experiment to participate in a driving simulator experience. For the scenarios, a 5-kilometer sections of local roads in Samcheok-si, Gangwon-do, where there are frequent freezing sections and many freezing accidents was replicated as a virtual environment. 3 types of warning signs for black ice are installed in a section where the warning sign for black ice are installed in real life. The driving and visual behavior that appear during repeated driving is compared and analyzed. To find the distance from the sign, where drivers change their behavior due to the sign, vehicle speed and gas pedal power were used to identify significant differences between the group that drove with no signs and the group that drove with signs. To determine the influences to determine the influence of traffic signs, the data sets of the 2 groups were compared. As a result, the location at which the drivers started to notably change their speed and gas pedal power were determined. The result provided excellent indications of where the sign influenced the drivers. As shown in figure 8, the location where the driver's behavior started to change signifies the distance from the signs where the driver began to exhibit significantly different driving behavior considering the presence of signs. As shown in figure 9, the result of new actuated warning signs for black ice indicated that the vehicle had considerable differences in speed deceleration from the weather condition, when the signs were actuated. Looking at the number of fixation and mean of fixation duration of each warning sign by type, the actuated sign showed a relatively large amount of attention. In particular, when the warning signs are actuated according to the temperature sensitivity, the mean of fixation is also increased. Comparison between people who fixed their eyes on the signs and who did not, according to the eye tracking data, the group who fixed their eyes on the sign showed significantly more speed deceleration and gas pedal power differences. As shown in Table 3, people who fixed their eyes on the new actuated black ice warning sign showed more speed deceleration and gas pedal power differences in both curved and tangent sections. As shown in Table 4, it was found that the conventional static warning sign did not lead to a notable differences in drivers' deceleration behavior in all classes. Meanwhile, the new actuated warning sign for black ice led to a significant difference in drivers' deceleration behavior in all cases, related to the no sign cases. As shown in Figure 10, the experiment found that the new actuated black ice warning sign led to a significant difference in drivers' pupil dilation. The experiment had not touched the correlation between type of warning signs and pupil dilation behavior for the purpose that the experiment did not weigh on visual workload of drivers. However, the analysis of pupil limiter differences in sign types indicates that further research on warning sign association with pupil dilation is needed. Through the experiments, we have found that drivers drive cautiously through deceleration behaviors in areas where attention is needed. The study confirmed that the new warning sign actuated to weather condition has the effect of drivers' speed reduction and inducing safe driving. This study has shown how further investigation of the correlation between drivers' visual behavior and environmental property of warning signs are needed.